Okay, so we have the first of our customer presentations today. We've got Robert Schultz and Heidi Lee from the RCMP, and they're going to show us how they're using FME and to improve their productivity. So, thanks, guys.
Great. All right, thanks, Craig. So my name is Robert Schultz. I'm the GMX coordinator for the RCMP in British Columbia, and Heidi Lee and I here are going to talk a little bit about how our deployment of FME Workbench has improved our productivity. So I'm going to start off with a brief overview of the RCMP Geomatics unit and the work we do for the RCMP. Then we're going to talk a bit about how we use FME for our map data updates, how we use it in GPS log mapping, and then we're going to wrap up and be available to answer any questions you might have. So the RCMP Geomatics and Mapping Unit, we provide a very wide range of geomatic services to the operational and administrative units of the RCMP across the province. These services include analytical and administrative mapping, things like doing some crime mapping, providing boundary maps to units as they require it. We maintain and manage a GIS server and develop a number of applications for some of the units in the province. We provide advice and guidance on the use of geospatial technologies and data. We maintain a province-wide base map of data that many of our end users depend on for their mapping needs. This includes a centerline road network, lakes, parks, police jurisdiction boundaries, First Nation reserves, to name a few. We are the main point in contact for resolving street address issues in the dispatch software. So if an address doesn't validate, people ask us to figure out what went wrong and to fix that. And we also produce some custom map data for a number of applications. And so today we're going to talk specifically about how FME has allowed us to really streamline our processes and improve our productivity, particularly around our map data updates and GPS log mapping. I've chosen these two particular processes because these are core to our unit's work, and they're core to the RCMP in British Columbia, and both of these processes require very timely completion. So for map data updates, the PRIME system, which stands for Police Records Information Management Environment, which is nice and big, the PRIME system provides all the dispatch and the records management system for the police forces across the province. All of the police forces use it, and it's nice. It's a good system for sharing information, but we specifically provide mapping support for the RCMP jurisdictions across the province. The system is divided up into 3 servers that cover their own geographic area: the north, southeast, the Vancouver Island, and the Lower Mainland. Each of these servers get their geographic data updated on a quarterly basis, and this results in a monthly update for us to push out. Now, what we specifically provide is when the geographic data is updated in one of the PRIME servers, we provide a series of shape files that are produced for the map applications on the dispatch workstations and on the mobile data terminals in the police cars. In addition to these custom shape files for dispatch and for MDTs, we also produce a series of attribute spreadsheets that represent how the street file works, and those are provided to the actual detachments across the province for their purposes. So I'd like to hand things over to Heidi right now, and she's going to go in to talk about how we're using FME to make this process much easier and much more productive. Heidi?
Thanks, Robert. When we receive map data updates for each server, the map data requires to be massaged before it can be used effectively in a dispatch map viewer. Up on the screen here is a screenshot of displaying the north-south-east region, and what gets displayed is the police map data, the location of the calls, and the location of the police cars. The different colored zones are the various patrol zones within each police jurisdiction. Initially, a single shapefile is provided with proper attributes for all the zones across the server area during an update. But due to the map viewer limitation, where we cannot symbolize on attribute data, we have to split up all of the different zones into separate shapefiles. So all of the pink polygons would belong to Zone A shapefile, and all of the green, Zone B, etc. As well, additional attribution needs to be added to the roads shapefile to display the address range and street names along the bottom of the map viewer when the dispatcher hovers across the road. Before FME, some scripting was developed inside ArcMap's model builder to automate portions of the process, but it still required a significant amount of manual interaction to produce the final product. As well, multiple models had to be created to accommodate the update. You couldn't start the next model without finishing the previous one, and initially this took us 1 to 1.5 days to process. But with FME, it has reduced our time to 2 hours. The map viewer requires the associated index files, SVN and XVX, to work efficiently, so we need to take an additional step of re-exporting the shape files in an ESRI product. This is an overview of a map data update FME model. I just kind of wanted to just show an overview. The red circles display all the inputs, and all the green circles display all of the outputs. So there's a lot of parallel processing going on. And so with FME, we can just let it run, and we don't have to wait for each process to finish before we start the next one. Here's a closer look at 2 parts in the model. This part joins the north-south-east street data with the street data from the Lower Mainland. It adds additional fields and calculates the minimum and maximum value of the address range and concatenates it all into one display field. So we end up with a field, for example, 100 to 200 Main Street, and that's what they would see at the bottom of the map viewer when they hover over a road. The minimum and max values are calculated by the script in the Python caller transformer. One particular issue that we deal with is different projections across the province. The north-southeast and island uses BC Albers, while the Lower Mainland uses UTM-10. As you can see, the reprojection transformer comes in handy, especially when dealing with data from different districts. For this portion of the model, this input, the municipality codes table, is joined with the address, intersection, and range files, populates the appropriate fields in each data set, and then exports them out as a shapefile. We also have another workspace that uses those shapefiles to create the spreadsheets that the detachment uses. That concludes the map data update portion of our presentation, so I'll hand it back to Robert to introduce the GPS log mapping.
Thanks, Heidi. So the GPS, all the police cars within, most all the police cars within the province are equipped with GPS units. This allows the cars to be tracked in a real-time fashion, and this helps facilitate the dispatch of the closest, most appropriate car to a particular call of service. And it also allows the operation commanders to be able to ensure that the cars are geographically distributed appropriately so that they can have the right kind of coverage. Upon occasion, we're called upon to provide a map of where the cars have been and showing the location history for that car. This used to be a very manual process, but with FME, we've been able to provide a much more automated, more efficient method of taking these raw logs and producing some spatial data that we can do the mapping with. So Heidi's going to take some time to outline how exactly FME helps us achieve that, and also how to deal with 2 very specific issues that we've come across with our logs, the size of the logs and a fairly newly discovered variable field format. So Heidi.
Thanks, Robert. Up here on the screen is a sample record from a GPS log. To import the GPS log into ArcGIS, we require a date time field to be calculated from the raw log. The date is extracted from the NDT date time field and the time from the GPS time field. The two values are then appended together to produce the ArcGIS time field, which we set to text because of leading zeros, and that's just a whole other issue. This process was originally done using a spreadsheet, template, and formulas, which was then used to create the feature class. As the demand for mapping of GPS logs increased, we encountered several issues that the use of FME helped us deal with. The manual spreadsheet process became impractical once we started dealing with larger GPS logs. Most logs typically have thousands of records, but a server log for an entire day can have over 400,000 records. Sometimes these server logs include the GPS data from all of the police vehicles that were out that day in that server. The spreadsheet method was a time-consuming process that could take hours in the case of 1 or 2 logs, or days or more with full day server logs. It became impractical to process the raw log using a spreadsheet, especially dealing with the limitations of the number of records that you can even display in the spreadsheet. Prior to implementing FME Workbench, the process of manually importing a normal log into a spreadsheet, using the set formulas, importing into ArcGIS, and producing the map took about half a day. Multiple logs would take many days and was compounded by limitation of the number of records the spreadsheet software could handle. Automating the data processing steps has allowed us to reduce the turnaround time of a single GPS map to about half hour or so. This has been particularly valuable in allowing us to complete large requests in a reasonable time. For example, a month of server-wide GPS logs can be processed in about 11 hours or so on the server while we work on other tasks or overnight, and then the map can be produced in a day or so. I'm now going to do a quick overview of the GPS log FME model. When you run the model, you are required to set your parameters, the input where you can select one or more GPS logs, select whether or not it was daylight savings time when the GPS log was recorded, and the output file geodatabase. We also have some QA/QC tools in place throughout the model. This logger transformer will log all records without an XY or time value to ensure that the entire GPS log is processed and that we're not missing any records. This is a test filter and sets the projection based on the unit ID of the police car. Every police car has a 2-unit ID that starts with the detachment 2-letter code. Based on that 2-letter code, we can determine what server it is and therefore what projection it should be in. At this unit ID test filter, I've also included a visualizer that will display any records that does not pass the test filter. So if necessary, we can always add a new unit. This portion of the model calculates the date and time. We have 2 test filters here, and then I'll explain a little bit later as in why we have 2. These transformers add extra fields for easier map making and labeling, and at the very end is the output file geodatabase where all of the logs will be placed into. Initially, we had used shapefiles as the output, but once we received some more server logs, we encountered the maximum number of records for a shapefile. As GPS hardware was upgraded in the police cars at different times across the entire province, it was discovered that the field for the GPS time began to change from 5 characters in length to 6. In some 5 characters represents the time in seconds, while the 6 characters represents the time in hours, minutes, seconds. The addition of decimals and zeros always complicated things. We're not sure why the different GPS and different MDT models, some of them have the decimal, some of them have following zeros, some of them don't have following zeros, and it created a bit of a headache for us. So we ended up with 2 different time formats, seconds and hours, minutes, seconds. But both, as you can see, could be 6 characters in length, depending on the decimal and the following zeros. This resulted in using 2 test filter transformers. With the first test filter, with calculating the time, I had it set so that when the string length is 5, it will convert it to hours, minutes, seconds. If the string length is 7 or 10, the value will remain, and if the string length is 6, it goes into further processing. In this further processing, the attribute gets split by the decimal, if there is one, and all following zeros get dropped, and then runs through the test filter again, where now 5 characters in length is seconds, and 6 is hours, minutes, seconds. And at the very end of this portion, the time is then converted from Greenwich Mean Time to Pacific Standard Time, as well takes into account whether or not the daylight savings option was selected prior to running the model. We had a lot of trouble with this section, especially with the scripting within the TCL caller, but with the assistance of FME, we were able to successfully complete the workspace. FME was the most useful with the calculation of time due to variation in the data across the province and has been particularly valuable in allowing us to complete large requests in a reasonable time. The model may look complicated and probably could have been done very differently, but it works and reduces human error with the processing of GPS logs. And I'll now pass it back to Robert to wrap up.
Thanks, Heidi. So hopefully we've been able to highlight some of the ways FME has really helped us improve our productivity. One of the key things it has done is it's really helped simplify the data processing. We no longer have to have several scripts that we have to manually run ourselves all the time. We can just put all the data at one end, run the script, and out it produces all of our custom map data. It's been allowed us to be able to handle these variable field formats a little more effectively, right? We don't have to analyze every record or sort it on the field to try to find out where the 5 characters or the 6 characters are and the decimals are. It can do the tests, it can find those, it can modify them and pass them through the rest of the script. Handles large files much better, and as we do more and more of these larger server type logs, we end up with much larger data sets. Leaving FME is really the only answer. And probably most importantly for, within our work environment, often things need to be done in a fairly expedient fashion. And this FME has allowed us to really get a timely turnaround on these very 2 critical data sets. So at this point, I'd like to thank you for your attention, and I'm be able to take any questions from the audience or anybody on the inner tubes.
Yeah, we'll just run the mic over to you so people online can hear the question as well too.
You mentioned that you used a TCL transformer, and I found TCL very difficult to work with. Can you tell us why you use TCL instead of a Python transformer?
When we first created the workspace, we actually started using FME without actually going to any training. We had to learn things very quickly. So we did get a lot of assistance, specifically from Mark Stokes, and he was actually the one who kind of said to use the TCL caller, so that question might actually be best suited for him.
I mean, also to be honest, we don't have a lot of experience with Python in our shop, so wouldn't necessarily be aware of it. So.
Actually, Robert was wrong. We do use Python in our work. Yes. We do use.
That's why I'm the coordinator.
I am more familiar with Python, and so earlier in the earlier workspace, I did use the Python caller because I actually kind of knew what I was doing. But with the TCL caller, Mark picked it, and he was the one who assisted me with the script and converting the time. And I guess he just thought that that transformer was better than the Python. Yes?
How do you manage the time zone shifts as they're driving along when they cross from Mountain to Pacific?
Pardon me, can you repeat the question?
When a car crosses from Pacific to Mountain time, the local time would change. Are you trying to detect which time zone it's in, or how are you tracking that?
Well, the different attachments across the province, they actually, even though I think, was it Cranbrook?
Yeah.
Cranbrook, I believe they use local mountain time, but everything in E Division, which is British Columbia, everything is done in Pacific Standard Time. The laptops are done in Pacific Standard Time. So it did cause some confusion when investigators request that the times be in local mountain time. So if that is the case, then I'll just convert it myself and do it specifically for them. But I've only had one of those requests in the last 3 years. So other than that, everything else is recorded in Pacific Standard Time.
Thank you very much.
Thank you.